This is a demonstration of the Unitron Weight Driven Mechanical Clock Drive, classic piece of machinery from about 50 years ago. This clock drive is driven by the following weights. There's a fairly substantial weight there, and then there's more weight that you can put on it, of course. You wind it up and the weight slowly falls. It takes maybe 10 minutes or a little bit more for it to fall all the way to the ground. As the weight falls, it causes the mechanical movement inside, which is very much like a clock, to drive the telescope, and it causes motion through these shafts. I'm going to try and show you the shafts. These shafts connect up to the telescope itself, right into the right ascension drive, and that causes the telescope itself to then slowly move and track the stars. In this particular case, I've got it set up on a 3-inch telescope, which is strictly for demonstration purposes only. This clock drive was designed to drive a 4-inch or perhaps a bigger telescope than that. I've got a 3-inch in my living room, and this is set up strictly as a demonstration. You can see the governor going around. That's a 3-ball governor, and in a minute here I'll stop it so you can see what's going on there. There's a large drum, and the weight is pulling on a cable that causes that drum to have a good deal of tension on it. And of course the governor simply slows it down, slows down the falling of the weight. You can increase the amount of tension and therefore increase the speed. You can also change the speed here. I'll try and demonstrate this. This knob here will change the setting, and it takes a little bit of time. It takes a few seconds for the governor to actually feel that and slow down or speed up. I think you can see it's probably already slowed down a little bit. And I can certainly, well, I've caused it to stop now, so you can get a sense of what the 3-ball governor looks like. Now, as I release the tension a little bit, it'll start to pick up speed, and it'll take it a few minutes to get up to some equilibrium speed. Once you tune this in, it's very, very precise and quite consistent. I've actually watched it drive a telescope, a 4-inch telescope, and at 150 power it tracked Jupiter across the sky for 10 minutes without any additional adjustments once I got it tweaked in. First time I saw one of these was at the Riverside Telescope Conference. I think it was 1988. In the middle of a dark field illuminated by a red light over the top, it looked like it was a UFO from outer space. Quite beautiful. Hope you enjoyed the video.